Okay, this is going to be a little information on the history of manufacturing, just to give you a little background. We have folks in this class who are from a wide range of backgrounds. Some of you guys are in the industrial supervision program, and you're already experts probably in Lean and the Toyota production system, but some of our students will be in GET. This is the first introduction they really have to Lean. And then we have students from other majors as well, so this will be the first introduction perhaps for them too. So if you're already an expert in this subject, just think how much you're going to have to add to the class. Okay? So this slide shows how manufacturing is part of the U.S. economy. All right? And you can see here, all right, that manufacturing accounts for 20% of the United States GDP, the gross domestic product, all right, and it employs 17% of the U.S. workforce. If we looked at those numbers in South Carolina, they would be even higher, okay? A greater percentage of our domestic product and our workforce are employed in manufacturing, okay? All right, so prior to manufacturing, and prior to the 19th century, everything was essentially a handmade good. Things were made by artisans, and all products were handmade. Today, we still have artisans and craftspeople like this, but it's more of a hobby or something people do for a specialty for crafts to make money, those kinds of things. They make beautiful, handmade, high-quality merchandise, okay? Okay, so prior to the 19th century, there was a guy named Eli Whitney. You guys probably all know he invented the cotton gin, all right? He didn't have great business skills and went bankrupt due to that. So then he left the South, traveled north, and started over, okay? He took a job mass producing muskets, okay, and led to the invention of the first milling machine, and he realized that he needed to break the production process down into smaller parts that did not require great amounts of skill. So he came up with the first idea of interchangeable parts. He also had this revolutionary idea, which is hard to believe that it was revolutionary, but that workers in the factory should be treated with respect. Okay? And that idea initially did not catch on in U.S. factories. Okay? So while we credit him with the invention of the cotton gin, which is important in the history of the war between the states and those kinds of things, the biggest contribution he made to manufacturing is the idea of interchangeable parts, and also the work that led to the modern milling machine. Okay, so then we have Henry Ford in the early 1900s. All right, and he revolutionized manufacturing using the assembly line. He wanted to speed up the manufacturing process by breaking it down into smaller parts so that unskilled laborers could be used. If they didn't have to know everything, they didn't have to know very much at all. All right, so he had a lot of problems with his labor force initially because everything was repetitive and menial, and that wasn't the kind of work people were accustomed to, and it caused a low morale problem. So the work was dangerous too. Remember, factories didn't have the safety conditions they do today. Their studies show that, or their records show rather, that they had about 200 severed fingers in the year 1911 alone. Okay, so then he began to improve morale. He doubled the pay in 1911 from $2.25 a day to $5 a day. So that increased production, and they began to make about 8,000 tin Lizzies. That's what the car you see in the picture there is called, in a day. And the price dropped of that car to $300. Now think though, these folks made $5 a day. This costs $300. So these folks were not driving that car, obviously. We're not driving a car. So he was also, Ford Motor Company was actually later also responsible for the first death by a robot, and that was in the late 1970s. A worker was hit in the head by a robotic arm. Okay, so changing speeds. In the early 1900s, Kichiro Toyota, okay, who we credit with lean manufacturing. Toyota, and you hear I'm saying that like the car, because that became Toyota Manufacturing, Toyota Motor Company. They developed what's called just-in-time manufacturing. And just-in-time, the parts get to the assembly line just as they're needed. So for instance, if we're talking about the BMWs that are made in Spartanburg, the dashes get there from plastic omnium just as they are needed. Or maybe those don't come from plastic omnium, they may come from the place in Fountain Inn, but the parts get to the line just as needed. Sometimes things are cut so close they even have to put a holding part, a temporary part, in the place of things, okay? But when you don't have money tied up in inventory in warehouses, that saves money, okay? It also saves space. Toyota also introduced the idea of Kaizen, which is literally called good change, is what that word means. And it means continuous improvement with employee input, okay? So the Japanese distinguish between Kaizen, which is continuous slow change, from innovation. Innovation is radical change, okay? So lean manufacturing also became known as the Toyota production system. There's an entire book on that which you can get. That the Toyota production system is the systematic elimination of waste, okay? And that phrase was coined in the early 1990s, okay? People still use lean manufacturing today. But the systematic elimination of waste centers around 5 areas, okay? These are the 5 areas that drive that: cost, quality, delivery, safety, and morale, all right? Okay, so a history of manufacturing. In the mid-1900s, the Webb Company creates the first electronically coordinated conveyor system, okay? And you can see some conveyor systems here, different kinds. Overhead, underneath, very typical to what you would expect to see, all right? These folks introduced conveyor systems actually to Henry Ford. All right, they continue to make conveyor systems today. All right, so manufacturing today, some of it centers around some other automated pieces. The automated storage and retrieval system. That moves material horizontally and vertically between storage compartments and transfer station. It can bring it to the process line. It can bring it out to a control panel where an operator dials it in. Actually goes and retrieves the part and brings it out automatically. Okay, an automated guided vehicle. All right, sometimes those are also called self-guided vehicles. Those are in use in plenty of factories in our areas, and they're computer-controlled system. They use pallets or other devices to transport work pieces. They can use it to take numerical control machines. They can deliver work to an area. They can pick up work from an area and be sent somewhere else. And they're part of a flexible manufacturing system. The very first place I worked in manufacturing actually had 2 self-guided vehicles. Ours were used to deliver mail and hot jobs around the plant, and we call them Tweedledee and Tweedledum. However, Tweedledum was dumber and sometimes had more accidents, so we had to be careful with him. Okay, then the other one is artificial intelligence. That's where machines learn from experience, from what they've done previously. You might think about this like if you've ever made a change in Word or PowerPoint and you changed how a bullet was formatting, and then the next time it automatically adapted. That's kind of a type of artificial intelligence. It learned from the experience, okay, that software did. And so in this case, the software reads what you're doing, it learns from experience, and it changes what the hardware is doing there. All right? Okay, so continuing on. Computer integrated manufacturing is what CIM stands for, and that's how we say it. It is a factory or company-wide philosophy for planning, integration, and implementation of automation, okay? It is a way, it does not eliminate workers, but it does change the job workers have, and it also changes the skill level to be higher, so it actually increases the pay, all right? Then if we look at this manufacturing enterprise wheel here, okay, this shows that the customer is the center of all manufacturing activities. That's why we engage in the activities. People and teamwork are an important part of it. It's about shared knowledge. You can see here, this circle, outer, okay? And then the key processes are an important part, what the resources and responsibilities are, and the infrastructure. Okay? So let's talk about Kaizen a little bit. That is the Japanese word for improvement, okay? And it's based on continuous improvement by everyone, all right? And then we also have something called a flexible manufacturing system, all right? This is a work center that can be adjusted. Conveyors could be moved. The robot could be moved. The end effector could be changed on the robot to make it do different things, all right? You can adapt the system to a changing need, all right? And it's efficient. All right, the other thing is it can increase productivity by as much as 50%. And here I'm showing kind of a robotic arm in this clip art. It's spot welding or placing something on an automobile line. But that robot will do that job repetitively and not complain and not get bored. All right? Okay, just in time. See the clock? All right, JIT. The objective here is to eliminate waste, all right? You can produce mixed products. It doesn't mean you necessarily only make the one thing just in time, all right? Just in time facilities, workers are going to be cross-trained, but they are going to be more valuable because of that. Okay, the Toyota Production System, TPS, that's what we call lean manufacturing, all right? And that began in the 1980s, all right, and then in the 90s we began to call it lean. In this system, everything is highly coordinated. You want all the activities that are involved in production to happen at a specified time, all right? You want to minimize storage, so you don't want there to be a cost of goods in storage, all right? And so the combination of just-in-time, the Toyota Production System, lean manufacturing, okay, started earlier, but they are still very popular today over 20 years later, all right? The Toyota Production System has been widely used in automotive. It competes with mass production, okay? It employs a lean production strategy. There are not going to be a lot of people standing around doing nothing at work, all right? Lean manufacturing, we say that is the systematic elimination of waste, all right? And for that to work, the entire system, all the people, from the lowest operator to the plant manager, have to participate, okay? This is the lean manufacturing video, and I'll ask you to go offline and watch that, all right? Okay, Six Sigma. All right, that is a quality measure that is statistically based, and it means you are aiming for near perfection. All right, it produces fewer than 3.4 defects per million. All right, and it uses the statistical tools to minimize defects and maximize production. Six Sigma process also identifies and corrects the causes of defects. All right, it utilizes the 5 whys to uncover the root cause. Okay, and then this is a flexible manufacturing cell. This is a flexible conveyor system. These are storage racks. There's some milling machines there, robots. Okay, rapid prototyping. All right, that's a prototype made directly from a computer model. You don't have to take it to the machine shop. You don't have to get a machinist to make an initial prototype for you. Right, there are a lot of different technologies. Some are additive, some are subtractive. The most popular are additive three-dimensional printers, okay? There's stereolithography, there's 3D printing, there's selective laser sintering, there's fused deposition modeling, okay? So all these are methods. The most popular these days is really the three-dimensional printing. We have one of those in the back of the lab. You'll be able to see that, okay? Work cell. Like I said, this is a work cell, all right? It's the manufacturing resources arranged in a group. You've got milling machines, you've got a lathe there maybe. There's a robot somewhere putting pieces on and off the conveyor system. There's a storage area, okay? And this can be reconfigured if you need to do something different. Work envelope. That is the range of motion of a robot or a machine, okay? If you place the robot over here in the corner of this room, its work envelope is not going to allow you to reach the conveyor, all right? And degrees of freedom. Degrees of freedom, every axis that a robot can move on gives you a degree of freedom for individual movements. The more degrees of freedom a robot has, the more accurately it can do a job. All right, and these are some references for you. Okay, you can look some of those up too. If you would like more information, you may want to use those in your project that's coming up. All right, I hope this helps.